So now we come to fractions with division. And so as we learned this past week in class that we don't actually divide fractions. We actually flip them, the second one, to make it an inverse. So the first thing that we're going to do with this question, we have three fractions, is we're going to create them either from their mixed form into an improper form. And we're also going to make our whole number, which is 3 here, a fraction. So 8 multiplied by 1 gives us 8, and we're adding 7 to that. So our numerator is 15. The denominator stays 8. Divide by 3 over 1. That's how we make a whole number. A fraction it's simply over 1. 4 multiplied by 2 gives us 8, and we're adding that 1 to it, gives us 9, and that denominator still stays the same. So the first thing we're going to do is we're going to focus on our first two fractions, working from left to right. If we had a bracket around our 3 over 1 divided by 9/4, then we would do that first through our order of operation rules, but we don't. So we're going to work just left to right. So we still keep our first fraction the same, which is 15/8, but this time we're flipping our second fraction to be 1/3, and instead of division, it's now a multiplication. Okay, so now we're going to multiply our numerators together and our denominators together, which 15 multiplied by 1 gives us 15. 8 multiplied by 3 gives us 24. And then we'll bring down that last remaining fraction, which is 9/4. So we're going to do the same thing again that we did to the 3 over 1. We're going to flip our 9/4, okay, to be 4 over 9. And instead of a division, we have a multiplication. So now it's just a simple question of multiplying our numerators together and our denominators together. 15 multiplied by 4 gives us 60. 24 multiplied by 9 gives us 216. So because the numerator is smaller than our denominator, we just simply need to reduce this down. So if we follow our divisibility rule with 216, okay, our divisibility rule for 3 is that if we add up the numbers together, 2 plus 1 plus 6, that actually gives us 9, okay? So because the sum of the individual numbers equal 9, we know that 216 is divisible by 3, okay? And 60 is also divisible by 3. I hope that is a little bit more apparent to you, as 6 goes into 3 2 times, and we just bring down the 0. So I'm just going to move up here a little bit on the screen. So if we have 60 over 2/16, and we actually divide both the numerator and the denominator by 3, we end up with 20 over 72. So we still need to ask ourselves, can we divide this down further? And yes, we can do that. So I just keep reducing as much as possible. So the first thing I do is I divide by 2, because I know that our last digit 0 in our numerator and 2 in the denominator are both even, so they can divide by 2. So 20 divided by 2 gives us 10, and 72 divided by 2 gives us 36. And then again, can we reduce it down further? Yes, we can, again by a deduction of divided by 2. So 10 divided by 2 is 5. 36 divided by 2 is 18, and this is as far as we can go, okay? If you were able to reduce from the 20 over 72 right down to the 5/18, that's fantastic, good for you, okay? If it did take you the multiple steps that I needed to do to reduce, that's fine too. The point of this, the most important aspect that you need to remember is that, do you understand the process and why we do the operation, and are you getting the correct answer? So now we come to another question from your homework, which is on page 142, and it's question L. And again, we have division using mixed fractions, and because there is no brackets, we're first going to start solving the problem using our first two fractions. So the first step is to put these fractions back into their improper form and multiply that second fraction by its reciprocal. So remember your denominators. When you're moving from a mixed fraction back into its improper form, we'll still have that same denominator. So 3 times 8 gives us 24, plus the 1 gives us 25 thirds. 12 multiplied by 1 gives us 12, plus 5 gives us 17 twelfths. So at this point, it's still technically a division because we haven't flipped anything yet. So in order to actually continue with the problem, remember we don't technically divide by fractions. So 25 thirds will actually be multiplied by that second fraction's inverse, which is 12 seventeenths. Okay? So when we actually multiply this out, 25 multiplied by 12 gives us 300, and 3 multiplied by 17 gives us 51, and that is disgusting. Okay, at this point in time, do not change it back into a mixed fraction, as we still have this third fraction to deal with. So if we look down at the line below, I'm just going to write that 300 over 51. And it is divided by, and I'm going to change that 2 and 2/17 into its improper form. So 2 multiplied by 7 gives us 34. Adding 2 to it gives us 36, and that denominator still stays the same. Remember, we do not divide a fraction by a fraction. What we actually do is we multiply the first fraction by the second fraction's inverse. So we actually will end up having 300 over 51 multiplied by 17 over 36. And from here, you have two different options, okay? The first option is just to multiply your numerators together and your denominators together. But, I mean, right off the bat, like 300 multiplied by 17 is going to give you 5,100, and 51 multiplied by 36 gives you 1836. Like, those are incredibly high numbers to be working with. So the question you should ask yourself prior to just simply multiplying your numerators together is out of these fractions, can I reduce anything? Okay, and actually you can. If we look at our first fraction here, our 300 over 51, again, the divisibility law that I explained to you in class last Tuesday shows us that for the prime number 3, if all of the numbers, if the sum of the numbers equal or are divided by 3, the whole number is. So, for instance, 51, 5 plus 1 is equal to 6. Can 3 go evenly into 6? Yes, it can. It can go in 2 times. Same to be said about 300. 3 plus 0 gives you 3. Can 3 go into 3? Yes, it can. So we can actually reduce this fraction first by dividing our numerator and denominator by 3. So we can divide by 3, and what we end up getting is 100 over 17, and we multiply that by 17 over 36. Okay, now some of you actually have shown me this in class, and it does work. Okay, I just have not been taught this method, but here, right here, you have a 17 on your denominator here, and you have a 17 on your numerator here. So actually, these can cancel each other out. So you actually end up getting 100 over 36. And then we are going to, I'm just going to put an arrow up because I've run out of room. So 100 over 36, and now we're going to reduce that down further. So the question to ask ourselves is, well, how many times can 36 go into 100? And the answer, if you put 100 divided by 36 into your calculator, you get 2.7777778 or something like that. So it can go in 2 whole times. 36 multiplied by 2 gives us 72. And we're going to take that away from that 100 because we've already accounted for 72 pieces. So 100, take away that 72 gives us 28 for our numerator. Sorry, my writing is looking a little wonky. And our denominator does not change, okay? So right now we have 2 and 28/36. And the question is, can we divide that fraction component down any further? And the answer to that is yes. The whole number 2 stays a whole number. A common factor between 28 and 36 is 4. So if we divide 28 by 4, we get 7. And if we divide 36 by 4, we get 9. So the actual final answer, I hope that you've been able to get to, is 2 7/9. Okay? So I hope this has helped. If you need any extra help or you want other questions added for the videos, by all means, email me or ask me in class or in my office hours, okay? So I hope that this helps in your understanding. If not, please let me know. Thanks so much.